Tunneling under extreme conditions. We've heard of it for centuries, since the time of the ancient Egyptian civilization up to the very present day, and we've seen the treacherous workload that it entails. So, what's this new project that'll mandate the very same effort and amount of time to finish? Let's jump right into today's video and take a look at the new power plant that's cooking up in Switzerland. Before we begin, go ahead and subscribe to our channel for daily content. Pumped storage power plants are a type of hydroelectric power plant that can store energy and generate electricity on demand. They consist of two reservoirs situated at different elevations. During periods of low electricity demand, excess electricity from the grid is used to pump water from the lower reservoir to the upper reservoir, effectively storing the energy. When the electricity demand is high or during peak times, the water is released from the upper reservoir back to the lower reservoir, passing through turbines that generate electricity in the process. Switzerland has a long history of utilizing pumped storage power plants due to its mountainous terrain, which provides favorable conditions for constructing such facilities. Pumped storage power plants help balance the grid as they can quickly respond to fluctuations in the electricity demand. They are particularly useful for storing excess renewable energy during periods of high production and delivering it back to the grid when needed. When tunneling, there are several obstacles and challenges that can be encountered. Here are some common ones. Number 1. Geological conditions. The nature of the ground through which the tunnel is being excavated can present significant challenges. Different types of soil and rock formations can have varying levels of stability, which can affect the tunneling process. Unpredictable geological conditions such as fault zones, water ingress, or unexpected rock formations may require additional engineering measures and increase the complexity and the cost of the project. Number 2. Groundwater. Dealing with groundwater is a major concern during tunneling. High water pressure can lead to flooding, instability, and potential collapse of the tunnel. Effective dewatering techniques such as installing drainage systems or grouting may be necessary to manage and control groundwater. Number 3. Existing infrastructure. Tunneling projects often need to navigate through areas with existing infrastructure, such as utility lines, roads, or buildings. These obstacles require careful planning and coordination to minimize disruptions and potential damage to the existing structures. It may involve rerouting utilities, acquiring necessary permissions, and implementing safety measures to protect adjacent infrastructures. Number 4. Environmental impact. Tunneling can have environmental implications including noise, dust, and air pollution. Minimizing these impacts through proper mitigation measures is crucial to ensure compliance with environmental regulations and maintain good relations with nearby communities. Number 5. Technical and engineering challenges. Tunneling projects require specialized engineering expertise and sophisticated equipment. Handling large-scale excavation, ensuring proper ventilation, designing efficient support systems, and maintaining stability throughout the construction process are technical challenges that need to be addressed by experienced professionals. Number 6, which is cost and timing. Tunneling projects are often complex and subject to cost and time overrun. Unexpected challenges such as encountering hard rock formations or unforeseen ground conditions can lead to delays and increased cost. Effective project management, risk assessment, and contingency planning are essential to mitigate these potential obstacles. Tunneling involves working in confined spaces and hazardous environments. So this leads us to worker safety. Ensuring the safety of workers is of the utmost importance and requires strict adherence to safety protocols, proper training and the implementation of safety measures like proper ventilation, emergency exits, and regular inspections. The Ritom hydropower facility in Piarodal, Ticino, was operational when the Swiss Gotthard Railway was electrified 100 years ago. Already then, the Gotthard Massif's complicated geology presented challenges to the miners. With the available resources at the time, it was not possible to achieve the perfect underground alignment. Since then, the mountain has been marked by its overhanging penstock. Engineers have been developing a contemporary effective pump storage system since the 1960s. This is currently being implemented, and an underground pressure tunnel will be built in 3 phases as part of the entire replacement of the power plant. A substantially modified Herrenkenk gripper TBM is being used to excavate the middle of 1,500-meter-long inclined shaft. This project is but one word: unique. The main Schwanau plant's hard rock machine begins its drive 600 meters below the surface in a cavern that Lake Ritom has carved out of the rock. As a result, the machine is constantly securely trapped in the granite pile. However, the 3.23-meter machine diameter made it quite difficult to access the knuckle lever mechanism, necessitating a technical invention and optimization by the engineers. It may now be easily altered mechanically while driving by employing wedges that are moved by cylinders. On March 23, 2022, the miners successfully make their way inside the cavern. The mechanical tunnel driving is the major focus. In this field, there is not only a wealth of professional expertise and knowledge, but there is also access to the most up-to-date technical tools. Here are some driving-related excavation techniques. Number 1. The tunnel boring machine. Open using precast concrete components, drive and place the bottom. Number 2. The placement of tubbing segments and special driving with a TBM shield or hydro and muddy soil pressure balance shield. Number 3. Using road header excavators while driving. Number 4. Using a pipe screen or jetting device when driving. Number 5. Using drilling jumbos for traditional drive or drilling and blasting. And last but not least, special drivings like shaft sinking, sectional construction, and so much more. As the Marty Tunnelbau Group stated, our teams are presently engaged in the excavation of the equalizing reservoir, the preliminary cutting of the water drives, and the lower pressure tunnel. The existing power plant is being converted by professionals in order to later install the new frequency converter. Conveyor belt systems are being installed simultaneously over the Ticino River, the A2 freeway, and the new Piota train loading station. The required new material ropeway from Atlanca, which is 1315 meters, to Piora, which is 1847 meters, is also being prepared for and put together. A new facility will replace the nearly century-old Ritom pump storage plant in Switzerland, and the technology company Voith has received a sizable order for producing units at the site. For its client Ritom SA, a joint venture between Swiss Rail SBB and the Canton of Ticino, Voith stated that it will be in charge of the design, construction, installation, and commissioning of a new high-performance generating unit. The Ritom plant currently uses 4 Pelton turbines with a combined rated output of 44 molecular weight. The new facility will use significantly more patent producing units in their place. Voith will provide 2 Pelton 60 molecular weight turbines and a 60 molecular weight storage pump to achieve this. The diverse designs and functions of the generating units place demanding demands on Voith's engineers. For instance, the first machine unit will provide electricity for Swiss rail network trains to run at 16.7 Hz. The second will feed the 50 Hz public grid with the electricity it produces. The third unit, a storage pump with a 60 molecular weight capacity and a delivery head of more than 700 meters, will move water from the Airolo Basin to Lake Ritom in order to manage reservoirs and supply balancing power or operational reserve. The pump can offer the operating reserve for quick grid regulation and stabilization with the greatest degree of flexibility when used in conjunction with the turbine. This indicates that the new power plant will give the 50 Hz Swiss grid a 60 molecular weight feed-in reserve intake and balance. Additionally, by using back-to-back starting and synchronized with the grid, the 50 Hz Pelton turbines can aid to accelerate the storage pump. According to Christian Matten, project manager at Bouygues Hydro Europe, he said, "In this case, the power of the turbine is utilized to start the water pump. Ritom SA, the power plant's operator, had extremely strict design criteria for all components because of the unique significance of this facility. We constructed a thorough simulation model for the entire electrical and mechanical scope of supply and carried out relevant research in advance. We also performed transient pressure or water hammer calculations. As a result, we can make sure, for instance, that our equipment satisfies the stringent specifications of the Swiss transmission grid." The ongoing power plant project holds tremendous potential for transforming the Swiss energy landscape and addressing the growing demand for electricity in our region. With its innovative design, commitment to sustainability, and significant economic benefit, this project represents a crucial step towards a cleaner and more reliable energy future. As construction progresses and the power plant becomes operational, we eagerly anticipate the positive impact it will have on the community, providing jobs, reducing greenhouse gas emissions, and bolstering the energy infrastructure. With continued investment in projects like this, we can pave the way for a brighter and more sustainable tomorrow. What are you most excited about in regards to this new power plant? Let us know in the comment section below, as we're always open to discussion. Don't forget to smash that like button and subscribe to join the community of curious minds. See you later!